Hi everyone, this is Keneally, and let's talk a little bit about this device here. This is called a Newton's Cradle. Newton came up with it to analyze collisions, and we're going to do the same thing, but I've got some questions for you. But first, let's see a little bit of what this can do. So if I pull one back and let it go, we get one come off the other end. Pull two back and let them go, we get two come off the other end. Well, what if I pull three back? They've been matching so far, but there's only two there. So will three go off the other side? Yeah, that one just keeps moving. Well, how about four? This one's always really popular, all five. It also makes less noise. Let's change things up and go from the other end. Two. Three and two. This is the hard one. If they're out of sync, but let's go back to the original one, this right here. Now, according to Newton's law, well, let's say Newton came up with it, but let's say conservation of momentum. If one ball comes in, they have a mass of about 67 grams. It hits, we always get one coming off the other side. This one's not lined up perfectly, so we get a little bit of variation, but just one comes off the other side. And it comes off, looks like the same speed. So we got mass and velocity coming in equals mass and velocity coming out. But according to conservation of momentum, could one ball come in and hit and two come off at half the speed? Does that hold true with conservation of momentum? Do a little quick calculation, see if you can come up with it. Or if one comes in, can three come off at 1/3 the speed? Did that still hold with conservation of momentum? Because these are elastic collisions. Let's pretend that they're perfectly elastic. They're not really, but they're pretty close. How come it's always one in, one out? Not one in and then two coming out at half speed. Well, all laws of physics are followed at the same time, so look at conservation of energy, particularly since these are elastic collisions, conservations of kinetic energy. If you count kinetic energy, could one ball come in and two come out? Or does it have to be one ball comes in and one ball goes out? So compare conservation momentum solutions to conservation of kinetic energy. Or I shouldn't say conservation of kinetic energy, I say kinetic energy remains the same in elastic collisions. And see if it always has to be matching on both sides. Think about that, and I'll talk to you later. Bye.